let's see, this one, we are told that calculate, oh, okay. Any idea how we do this one? Just calculate the magnitude of the reactions at each of the supports. Where's my pen gone? So there's a reaction at each. Oh, I think my little pen is. Is it in the kitchen or something? Hang on. So you have a reaction at A and a reaction at C. The diagram shows it's a uniform rod. Any idea what that means? Uniform rod or uniform?
No.
All the weight is in the center, and so it's modeled as having all the weight in its center, and so its weight is 20, and so you've got 20 newtons in the very center. So let's say try taking moments about A. I just need to grab my pen 1 second. Oops. Okay. Yeah, so moments about A.
So am I supposed to get from A to C?
So you just take moments about A, and so like clockwise, anti-clockwise, the distance.
So I think it will be clockwise probably.
So let's say this 20 force. That's 2 meters away, and so what would that be overall?
40.
Yeah, and will that go clockwise or anti-clockwise?
Is it clockwise?
Yep, and so that means it's negative 40.
Yeah.
Okay. Oh no, that's not 2 meters. A to C is 2 meters. Any idea what A to that 20 force is? If it's uniform, the rod is uniform.
Does that mean it's in between 2 and 1?
It means it is 1.5 because it's half of the total. Total is 3. So it's minus 1.5 times 20.
Which will be minus 30.
Okay. How about the reaction at C? So we don't know the reaction at C, so we just write it as like reaction at C.
So for C, will it be 2 times?
So just write it as 2, like reaction at C. Plus or minus?
Plus.
Yeah, because that's anti-clockwise. And it says that these are in equilibrium. And so what do you know about these two?
Does that mean they'll be equals to 0?
Yeah. And so use that to solve for the reaction at C.
I think the answer will be 15.
So the reaction at C, oh, that's weird. Okay. Reaction at C is 15. Oh, it's not weird. Okay, how do we get the reaction at A? how did we get the reaction at C?
We did.
There was one other force, and that was the reaction at A. The reason why we didn't bother with that is because it would be like the reaction at A times 0, because we're at the point A. And so that would just become 0. So we took imagine you took moments about the middle. Yeah?
Yeah.
This here is 0.5. Because it's in equilibrium, 2 times the reaction at A would be equal to a half times the reaction at C. But the problem is we've got 2 unknowns. That's why you have to take moments at A to eliminate it, because it's 0 meters away from itself, and so that's becomes 0. So you just get one equation with the other one. So how could you get an equation with RA? Or how could you find RA?
Make RA the subject.
Yes. The most difficult way, that'd be the middle way, but that's just because I wrote this. What you could do, so we just found moments about A. You could now take moments about C. And that would, you'd have a reaction at A thing. However, there is an easier way, just like with simultaneous equations. It says the uniform rod has a weight of 20, and the total reactions have to add up to 20. And so the reaction at A plus the reaction at C must be equal to 20. And so use that.
Yeah, does that mean there'll be like reaction of A plus 15 is equal to 20?
Yeah.
And so reaction of A is 5?
Yes. And so reaction at A is 5. Well done. Okay, let's see. So yeah, you've got 2 unknowns, and so to eliminate one of them, you take moments about that point. Let's see, before we do that, oh no, I don't have any middle one, do I? We'll give it a go. Okay, how about this? Hang on. Let me just do one that's at least a bit halfway between. What goes here? No, mechanics. Hang on, should we be doing stats or something? I forgot. Should we have been doing stats? Am I crazy?
It's Friday, yeah.
Alright, can we do stats? We'll do stats twice next week?
Oh yeah, sure, yeah.
Okay, so moments, 4.1. That's silly, I'm just used to... Sorry, we want 4.3. Yeah. Okay, how would you do question 2? Yeah. So try question 2. Are you able to see it there?
Yeah.
All right.
So for reaction 1, do I need to do like Do I need to like do 1 plus 2.5 is 3.5 to start off with, or
No. Say anything you know about reaction 1 and reaction 2.
they're the same?
You don't know that?
Yeah.
I'd say R2 will be bigger.
Yeah. Do we know they're both going to be? Oh, we know if they're clockwise or anti-clockwise. I'm not sure.
What would be R1 plus R2?
0.
No. It'd have to be the...
Uniform rod. Does that mean they'll be equals to 7?
No. Total reaction is equal to total weight.
So 100.
Yep. So those two will add up to 100. And it looks like reaction 2 will be bigger. Let me think about this. Okay. So it could be like reaction 2 could be, 80 newtons and reaction 1 could be 20 newtons or something. The problem is you've got two unknowns. If you take moments about reaction 1, if you take moments about this point here, let's call this A. Over here, this is B. If you take moments about A, you would get like 0 times reaction 1. So that would eliminate that unknown because it's 0 away from it. Okay, how about the other two forces?
So how did you get 0, sorry?
It's like distance times force. Distance times perpendicular force. And A is a distance of 0 away from itself. So reaction 1 is perpendicular to A, and we're taking moments about A, so that would just be nothing. And so distance to 100.
Do I need to times 100 by m of A, or
Times distance from A.
so is that 2.5?
Yep.
So do I just need to times those three together?
No.
Oh.
2.5 times.
Times by
What force is 2.5 away from A?
oh, is it times 10 or something?
No, there's no 10 force.
100.
Yep. So it's distance times perpendicular force. And how about the remaining force? Reaction 2.
So will that be like M of B, where I need to now do?
No. You're taking moments about A. So
Yep.
you said 2.5 times 100. Okay. There's one more force to take into account.
The upwards force.
Yep. And so distance times force.
So is that gonna be 2.5 rec or something, or
2.5, what's it?
like times rec or something, or RA, sorry.
What's the distance from A to reaction 2?
3.
Yep. So it's going to be 3 times whatever reaction 2 is.
Okay.
And this first one, is that going clockwise, anti-clockwise? The blue one?
First, let's go clockwise.
And so positive or negative?
Negative.
That's it. It's at rest. And so what do you know about all the forces?
That they are going to be 0 or something.
They all add up to 0.
Yeah.
So you have, taking moments about A, we have this downward force that's going to spin this thing in this direction. Like A is like the pivot, the hinge. Reaction 2 is spinning it the opposite direction. And overall, if it's at rest, then they're not going anywhere. Okay, solve.
I can trace my calculator, can't I?
Yep.
Oh, even though we've got R1 and R2 here.
Well, 0 times R1.
Yeah. So does it just become minus 2.5 times 100 plus 3 times R2 equals 0?
Yeah, and that's why we take moments about A to eliminate it.
I got 250 over 3.
So reaction 2 is 250 over 3. How about reaction 1?
Do I need to just now do 100 minus 250 over 3 for reaction 1?
Yep.
And I got 50 over 3.
And so that is 50 over 3. That's great. Yeah, so you take moments about 1. Once you get that, it's a bit like simultaneous equations. It makes your life a bit easier. Okay, let's try this. So we are trying to find F, is it? Hang on a second. F, and there's a part B. Work out the reaction. Okay, let's try this.
Okay, so I need to do like 2 plus 6 equals, I need to do 2 times R equals 0, or
Okay, so if you're taking moments about A,
yeah,
you've got 2 times R. There's another force though.
times 50.
Well, what's the distance from A to 50?
2.
From A to 50.
Would it be like 4?
Yeah.
4.
So it's uniform.
And so now I've got 2 times R times 4. Do I now?
Distance times force.
And so do I now times it by?
No, there's no force down here. So this one is distance times force, 2 times r. This one is also distance times force. The distance is 4 meters. What's the force?
50 newtons.
Yeah, so 4 times 50. And positive or negative?
It will be positive.
Clockwise, or about A.
Oh.
So it's going to be negative. When you add or subtract all the forces, if it's at rest, they make 0. Okay, find R.
So do I now need to do like 2r minus 200 equals to 0, and so 2r equals to 200, r equals to 100.
Yeah. So R is 100. Use that to find the magnitude of F.
Do I need to do 2 times 100 or?
No. Total weight is equal to total reaction.
So 50 times 8. Well,
No. Total weight, total reaction. What's the reaction?
100.
Okay, so that has to be equal to the total weight. What are the forces acting down?
Weight.
Okay, what's the weight?
50 newtons.
Okay, any other force?
The reaction.
That's 100. Any other downward forces?
F.
Yeah, and so 50 plus F must be 100.
And so F equals to 50.
Yeah, strange enough, but yeah, F also equals 50. Okay, let's see. I did that one. We could do this. Let me just see. So we want 4.3. Is this the same book? Is this the I wanted the yeah. Okay, 1 second. Yep. Okay, let's try question 1. So each of these, the rod is always 5 meters long, always has a weight of 20 newtons. we've defined the reactions, the two reactions each time, one at C, one at D.
So do I need to like make like a downwards arrow of 20N for the rod?
Yeah.
Rod
Where does that go?
in the middle.
Yes. Okay. That's 20 newtons. And so use that to calculate the reactions at C and D.
Okay. So to get from D to the force to like the weight, it would take it's do I need to do like two is like the distance between them.
The distance between what?
C and 20 newtons.
Okay. Okay, so go on.
So I know it's uniform.
I recommend you take moments about C.
So is that when you say moments, is that like the distance between C and the weight, or?
So C is the pivot, and so this thing is like pivoting around that whichever way it goes. Now it's in it says it's like the middle of the clock, and then this bit is like the hand of the clock that's spinning around that point. And so what are the forces in relation to the point C?
The downwards weight and the upwards reactions.
Okay, so calculate the moment of each of those forces about C.
And will that be like? And will it also be equals to 0?
Yeah.
So will it be 1 times C is equals to 0, or?
We're taking moments about C, so it would be like 0 times reaction at C, if you like. So that eliminates the reaction at C.
So do I try to move on to D now?
Yeah.
And so will that be do I need to do 1 plus 3 equals 4?
No. The force, the reaction at D isn't at B. That would be 4 meters away. Distance times force. Base times height. From C to the force at D.
3.
Okay, and so 3 times
20.
That's not 3 meters away. The reaction at D is 3 meters away, and so it'll be 3 times reaction at D, whatever force that is.
Yeah.
Okay, how about the 20 force?
Is it then times 20?
No, that just means 20 newtons. It's distance times force. What's the distance from C to the 20 force?
2.
Why is it 2?
It's uniform.
Uniform means it's in the center.
So if it's a sensor, is it 2.5?
Yeah, it's 2.5 away from A. And so what's the distance from C to the center?
1.5.
Yes. And so 1.5.
Is it plus 1.5?
It'll be minus 1.5 because it's clockwise.
Okay, yeah.
For distance times force.
Do I now need to do from D to 20?
No. You did the distance, 1.5. What's the force?
Times 20.
Yes. And that's what you'd solve. So you've got two forces. You've got 1.5 times 20, and you've got 3 times whatever direction at D is. That one's anti-clockwise, it's plus. Second one is clockwise, it's negative. And solve.
Okay, and so that will be. I'll just put into my calculator.
Mm-hmm.
I've got that reaction at D is 1.
Yep. Okay. How about reaction at C?
So now, do we need to do? Do we have some sort of formula for where it's like RC plus RD is equals to 0?
Yeah, except the total weight is equal to total reaction. The weight isn't 0. What is it?
It is 20.
Yes. So reaction at C plus reaction at D equals 20.
And so is it going to be reaction of C plus 1 is equals to 20?
How did you get plus 1?
From reaction of D.
Oh, okay. Yep, reaction at C plus 1 equals 20.
And do I then just do reaction of C is equals to 19?
That's it. Okay. Part B. Do it all again.
Okay, so for the first one, do we do? Oh, so do I need to just put weight for all of them is 20 newtons?
Yeah, weight for all of them is 20.
Yeah. And so, am I going to do something like 0 equals to 2 times reaction of C?
What are you taking moments about?
Oh no, would it be reaction of D again?
Okay.
Minus
Mm-hmm.
0. I'm sure.
The weight is 20 newtons. The total length is 5, and it's a uniform rod.
Yeah.
And so where will that 20 newtons be?
In the middle. So at 2.5.
And where will that be in relation to C if we're taking moments about C?
Will it be minus 0.5?
0.5, yeah.
And
So it's always distance times force. That's the distance.
so I need to get the force.
Yep.
And so times by not sure.
What's the weight?
1, 2
So it's times 20.
times 20. Okay. And so do we now just have 2 times RD minus 0.5 times 20? And I'll just put that back in later.
Yeah.
Just give me a syntax error for some reason. No, I think I know why. Yeah, I got the reaction of D5.
Okay. Reaction at D is 5. Reaction at C.
And so do I now need to do a reaction of C plus 5 equals 20?
Yep.
And so reaction of C is equals to 15.
That's it. So let's draw the diagram first. So question C. So draw on all the forces that we need. So first of all, uniform rod. Well, okay. The weight is 20 newtons. Okay. So it has a weight of 20 newtons. Where does that go? For question C.
In the middle.
And so where will that be, let's say, in relation to C?
So will that then be... So if C is 1.5 and it's going to be so it'll be 1 away from C.
Yeah. And so I'll just put it there, let's say.
Yep.
And so what's the magnitude of this force? What's the size of this force?
20.
Yeah, so that's 20. What other forces are there?
Reactions.
Yes. So now we have all our forces on the diagram. Okay. Now let's find the 2 other forces.
And so is this where I now do so 0 is equals to
Hold on. So what are you taking moments about? Or where are you taking moments about?
and taking moment's reaction of D? Oh, actually, I'm taking the moment of C, but I'm going to use reaction of D inside my answer.
Okay, I thought that's what you meant. So you're taking moments about C. So that's like everything is pivoting around C. All right. And you said 0 equals because you know that the forces will add up to 0 because it's in equilibrium, it's at rest. And so, okay, go for it.
And so will it then be 0 is equals to 2.5 times by reaction of D minus 1 times 20.
Mm-hmm.
And then just solve for that on my calculator.
Yeah.
And I got 8. That reaction of D is 8.
So reaction at D is 8. Okay. Reaction at C, how do we get that?
We do 8 plus reaction of C is equals to 20.
Yeah.
Reaction of C is 12.
Well done. Reaction at C plus 8. Okay. Oh, hang on. I need to go back now. Okay. Too far. Okay, exam time.
Okay. So, unusual. So I'm basically using the same thing I was just doing just now.
Mm-hmm.
So is it going to be like a moment of C
Mm-hmm.
0 equals to is it going to be 1 times reaction of D?
C is more than 1 meter away from D.
So the length is 6 meters, and I need to do like
Let's
will that be like 4 or something? I'm not sure.
let's take moments about A and just try to get everything all in one go. See how that goes. So take moments about A.
So am I doing 0 equals to is that now going to be like
Yeah, actually, let me just see. Let's do it a different way. We'll go back to what we were doing originally because that's what we've been practicing. How could you express, what would be an expression for this length in here? You've got 1, 2, and x.
just y. Something I don't know.
Okay, and what do you know about the total length?
It's equals to 6. So would it be like x plus y plus 3 equals to 6?
Yeah. Make y the subject.
And so now it'll be y is equals to 3 minus x.
And so y can be written as 3 minus x.
Yeah. And so now do we do x plus 3 minus x plus
Hang
3?
on, slow down.
So,
Hold on. So moments about c, 0 equals, yeah, what is it?
will it now be 3 plus 3 minus x?
Why is it 3 plus 3?
Or is it just going to be x?
So you're at c, you're taking moments about c.
Yep.
Okay, so forces, distance times force.
So the distance is going to be x.
There's no force at A. So distance from C to one of the forces times the force.
So is it 3 minus x times 3?
Yes. 3 minus x times 30.
Do I now need to do like minus? Or should I be trying to find x right now? Or?
Just take moments about C.
And then do I then do minus 3 minus x plus 1 times reaction? Yeah.
So 3 minus x plus 1 times reaction at D. So which of these is plus, which is minus?
First is plus, second is minus.
First one is clockwise.
Okay, so that first one's minus, sorry. And also the plus, yeah.
Yeah. Okay. And then let's see. So we have that. Hold on, but we have x and reaction at D. So we've got two unknowns. We're also told this. Reaction at C is equal to 4 times reaction at D. Any other equation regarding RC and RD?
Just RC plus RD is equals to 30.
Yep, that'll do it.
And so is it now going to be should I have got the reaction C and D first?
Yeah, yep.
And so for reaction of should I just put into my calculator? Or no, should I get X first and then sub that in to get reaction of D?
Other way around. Because we don't know what x is.
If I did like x plus 3 minus x plus 3 equals to 6, would that be able to give me x?
Yeah, that will work actually, yeah. I think. No. They'll literally just give you 6. It's an identity. It's identical. It'll give you 3 plus 3 equals 6.
Oh, okay.
Reaction at C is equal to 4 rec D. These two are simultaneous equations. RC, RD, RC, RD.
And so I need to now sub in. So if I have to put in 4RD plus RD equals to 30.
Yep.
And then I can factorize out RD and get like 4 plus 1 equals to 30.
Yep.
And then just do RD is equals to 30 over 4 plus 1.
Sure.
And that would be equals to 6.
Yep. 4 plus 1 is 5. 4RD plus 1RD, 5RD. RD is 6.
And now to find RC, do I now need to do 4 times 6, which will be 24.
Okay. Work out the length x.
And so now I've got RC and I've got RD. Do I now need to do like put them in and?
Yep.
And do I now need to multiply?
No.
No. Okay.
You have an equation with x. You now know everything you need.
Oh, so now if I just do 0, do I need to just sub in 6 in for action to do?
Yep.
And so that would be 0 equals minus 3 minus 6 times the plus 3 minus x plus 1 times 6.
Yep.
So
Oops.
I got a few answers.
Okay. You should only get one. What'd you get?
And they weren't nice answers, so I'm not sure if I put it in wrong.
You can expand them manually.
And so
minus 90 plus 30x.
Oh, I know I did.
Okay.
Yeah, I got 11 over 4.
11 over 4. Me too. Great. 2.75. 2.75. Let's see. This will have to wait. You've never done these in school?
No.
Yep. Definitely not. This should have been much easier. Let's see. Not really a real deal. Okay, maybe we'll do this next time. Or maybe we should do like mechanics twice in a week. Stats twice in a week, something like that. But let's see. In general, just pick a point. So if you have to find... Okay, so this dude, his weight is 80. And the weight of this thing is 40. And that's going to be in the middle. So you might just say, okay, I'll take moments about C. And so it's going to be this distance times 40. It's negative because it's clockwise. Minus this distance times 80. Plus this distance times reaction at D. And that distance is 3 times reaction at D, and that will all be equal to 0 because it's at rest. And so you're just doing that every time. Maybe you just need to practice simpler ones. Anyway, yeah, how was that for you, Andrey?
I don't know, I did find it quite difficult, to be honest, but yeah.
All right, stats next time.
Yeah.
All right, any questions for me in general?
No, I don't think so.
All right, well, well done, Andrey. You did great, and look forward to talking to you again at the end of the week.
Okay, thanks. See you on Friday.
All right, take care. Goodbye. Bye. Hi, Genevieve.
Hello.
Hi, how are you?
Fine, thank you.
Are you ready to begin?
Yes.
Okay. So you said you want to do comprehension. Do you still want that or something else?
Comprehension is fine.
Okay. Better than fine. It's great. Let's find this. Let's see. Let's see. Did we do this one?
Yes.
I thought so. Did we do this one about how to take about a dog? Dogs are
No.
okay. Okay. Let's try this. What does this say?